Alright, so we are going to start off our calculus course by learning the basic principle of calculus. Now this is something that I did in advanced functions. I'm not sure if you'll remember or not because it was early on. And it's called something called the slope of the tangent. And what that looks like is that when we have a curve, we are going to try to find the slope of a line at a certain point on that curve. Now in grade 9 math, and probably a little bit in grade 10 and 11 math, you looked at finding the slope of a line, and it's not too hard because there's two equations. They're basically the same equation. We have slope, m, which is often called, I'm not sure why, is rise over run. Or we also have the slope is y2 minus y1 over x2 minus x1. So again, those are our slope of a line formulas. Now, when we are trying to find the slope of a curve at some point, and I'm going to say that that point is right here. I'm going to call that point x. Alright, so I want to find the slope of a curve at point x. Now, to find the slope of a line, you need 2 points. So I could grab another point over here. Let's see, I'm going to say at a different x value. Alright, and so if I go upwards, let's see, track upwards, and if I find the slope of the line, or draw the line in, there we go. So I could find the slope of that line, but it's not a very good indicator of the slope that we actually have at that point, which I could probably represent with my pen. Alright, so what I could do to get a better representation of the slope at that point is, let's move this point closer to my point at x. So let's say right here. And so again, I could find the slope of this line right here that I'm going to draw that connects my point at x with this new point or next point that I have. And there we go. Now again, that second line that I just drawn, if I found the slope of it, it's a little bit better than the slope that's actually at that point, the slope of the curve at that point. Now, those two red lines that I've drawn in there are what we call secant lines, because they take 2 points and we connect them and we find the slope of that line. So they're called secant points. Now, what I was going to, usually I draw in a few more red lines, but I don't want this diagram to look too crazy, is that what you'll notice is that when I drew this first point after x, and I found the slope of that line, man, that slope wasn't very good. But then I drew another point that was closer to my point at x, and that slope was a little bit closer to the slope I see of the curve at that point. But it's not good. And so what I'm trying to tell you is that if I move these 2 points, or I move this point closer and closer and closer to that point, the better our slope will be. And so what I can actually do is move that point, let's see here, really close, and I'll call that distance x plus h would be very, very close. And so if I drew my line in, again I'm going to draw a nice red line. And so again, the slope, if another secant line that I just drew there, is even better. Alright, and so I can find the slope of a secant line by using my grade 9 formula here, the y2 minus y1 over x2 minus x1. It's the same thing as rise over run, but rise over run is in words, and y2 minus y1 over x2 minus x1 is just notation. And so what I can do is I can find the slope of my secant line by taking y2, which would be this point right here, which in function notation would be f. Take your function f and substitute in x plus h, and you would get the height. And I would subtract y1, which would just be the height of our original point here, which would be in function notation f of x. In other words, I sub x into our function to get our y value, again, using function notation. Now on the bottom, I would have x2 minus x1. Well, x2 is actually what I'm going to call x plus h there. And this x here would be my x1. Alright, so I would have x plus h minus x1, which I'm calling again x. And now we got the slope is equal to f of x plus h minus f of x. And if I simplify the bottom, you can see that I have a, whoa! There we go. Have no idea why that happened. I got every, whoa. There we go. Are we all still good? That's a first. That's never happened to me before. Oops. There we go. Alright, so again, if I look at the bottom of my equation here, I have x plus h minus x. Alright, and if I take an x and I minus an x, all I've got in that denominator now is that h. Now, here comes the calculus aspect of what we're looking at here, alright? Is that, as I mentioned before, each time that I move this second point towards this black point here, my slope of my line gets more accurate. And so what I want to really do is move these 2 points, move that point so close to that x value that you can't even tell there's 2 points. In fact, there's only going to look like there's 1 point. There really is 2, but they're so close together, they look like 1. And so what I'm going to do is, I'm going to say that I'm going to decrease that distance so that it's almost nothing. Alright, so I'm going to write down that as h approaches 0, so I have h with an arrow towards the 0, so that is h approaches 0. We find the slope of what's called a tangent line. Not a secant line. Alright, so what I'm trying to tell you is that when we're trying to find the slope of this curve at a certain point, all these red lines that I have in there involve 2 points. So those are called secant lines. But when I'm just drawing a line at 1 point, right at our black point, that green line here is what we call our tangent line. So again, there is 2 points, but really there isn't because they're so close together. The distance between them is unmeasurable. It's so small, and so there looks like they're 1 point. Because of that, we have what's called a tangent line. And as you can see, if I'm looking at the slope of the curve at this specific point x, the green line is the best indicator of that slope, all right, which is the tangent line. And so, all this theory, this is the big theory today of calculus in general, to be honest with you, is that we're going to come up with a formula. And our formula is this, is therefore the slope of a tangent line of our function f of x, which for me was just this curve, hopefully you can see it now, at point x. So any point x, I just picked this one here randomly, all right, is equal to, we have our slope formula over there. Now I'm going to leave a space here, but I got f of x plus h minus f of x all over h. Now, again, the theory is that we're going to push these 2 points so close together that h is pretty close to 0, that we can't even distinguish the distance between these two. So what I say is I'm going to push it to the limit. So I have an LIM there. And I'm going to push h towards 0. And so there is the equation that we're going to use. All right, so that again is the equation of a tangent line. The slope of a curve at just 1 point, or 2 points, but really they're 1 again because they're so close together. All right, now that gets us into using this formula. A lot of algebra coming our way here. All right, so we get to our first example. Determine the slope of the tangent line on the curve f of x, which is just a parabola equals x squared. So y equals x squared at the point 3, 9. So just to give you, I picked a real simple function here, just to give you an idea what we're looking at here, is you have a curve, or you have a graph here. Here's our function y equals x squared. And we have a tangent line at point 39. So our x value is 3. And at x equals 3, it hits our curve at 9. And what we want to know is the slope of this red line. I'm predicting just by my sketch there, which I think is relatively accurate, that we're going to have a positive number. But we're going to figure out that slope. And so what we're going to use is our equation here. So the slope of the tangent is, we're going to look at the limit as h approaches 0. We have f of x plus h minus f of x divided by h, and we're looking at it at x equals 3. All right, so again, we did work with limits with advanced functions, for those of you who are in my advanced functions class. All right, so now I'm going to substitute into my equation here. So I have the limit as h approaches 0. It says put x plus h into my function. Well, x is actually 3. All right, so instead of x squared, I'm going to have a 3 plus h squared. So I substituted 3 plus h into my function. And then I have minus f of x, or f of 3. So plug a 3 into your equation. Well, 3 squared is 9. Which makes sense because that's the point, 3, 9. All right, and divided by h. Now here's the problem, is what we want to do, is that we want to substitute h as 0 into the equation. The problem is we have an h in the denominator and you can't divide by 0. Big problem. So what we're going to do is we're going to simplify this polynomial on the top of our fraction and our limit, see if we can make something happen. All right, so I'm going to simplify it. See if we can get rid of that h in the denominator so that we can sub in a 0. Alright, so I have a 3 plus h squared. So I'm going to expand that. Alright, so I have a binomial squared. I have 3 squared. That's a 9. Then I go 2 times h times 3. Well, 2 times 3 is 6 times h is going to be a 6h. Then I take h and I square it. Again, that's just doing a binomial square. And then, oh, by the way, I have a minus 9. All divided by h. All right, now I do have some simplification I can do. I have a 9 and a minus 9. Those are gone. Those, well, cancel each other out. And so now I have the limit, let's go up here, the limit as h approaches 0 On the top I have 6h plus h squared. And of course divide by h. Well, I still cannot substitute in because I have an h in the denominator. But what I'm going to do is, on the top of my polynomial there, I'm going to factor out an h. Alright, so now I have the limit as h approaches 0. Alright, I have a 6h plus an h squared. So I can factor out an h and I'd be left with h times 6 plus h in the brackets. And then down below, I still have my h. But now I have an h in my numerator and an h in my denominator. I can divide those out. And now what I'm left with is the limit as h approaches 0. All I have is a 6 plus h. And for all that work, now the denominator of h is gone, so I can plug the h equals 0 in. And I just end up with a big 6. So the slope, what that's telling me is, if I'm finding the slope of the tangent line, which is my red line, to my curve f of x, which is that green parabola, the slope of this red line would just simply be 6. Alright, now let's try a couple more, a little tougher ones. Let's see. Leave that there. Probably going to use that. All right. So example 2. Yeah, we're going to get into some a lot of algebra. All right. Example 2 says, determine the slope of the tangent line to the line, it says, f of x, which is, we got a new function here, much more complicated, 3x plus 6 all over x, and they want to find the slope of the tangent at x equals 2. All right. So once again, we are going to use our limit. Example 2 here, I'll throw a 2 in there. Alright, so we're going to use our limit as h approaches 0. We have f of x plus h, or I might as well put in a 2 plus h minus f of 2 all over h. So there, I already just substituted in the x value. But now I have to substitute everything in to the original function. Alright, so now here we go. We have the limit as h approaches 0. Put 2 plus h into my function, which means wherever there's an x, I'm going to put a 2 plus h. Alright, so I have a 3 times 2 plus h plus 6. And that's all over x. Yikes. Which is going to be 2 plus h in the bottom. Alright, minus f of 2. F of 2 means plug in a 2 into our equation here. So let's see, I'm going to do that over on the side. F of 2, we'd have 3 times 2 plus 6 divided by 2. Let's see here, 3 times 2 is 6, plus 6 is 12. It's going to be a 6. I believe, yeah. A 6, alright, minus 6. Now that is all over, this is where things get messy here, h. Yikes. Alright, now, if I want to simplify this, the first thing I'm going to do is I'm going to put these two terms together. But I can only do that if I have a common denominator, because we got a fraction up here. We got a fraction inside a fraction, and we'll deal with that. But the first thing is I need a common denominator here, and the way that I can do that for that 6 is that I can multiply both the top and the bottom by 2 plus h. Because if I do that, I get a denominator of 2 plus h, which gives me my common denominator here. And, well, you can see that these two, if they just divide each other out, you'd still be left with 6. Alright, so now, again, a lot of algebra coming your way here. So again, we have the limit as h approaches 0. So I know that my top part of my fraction here, like I said, I got a fraction inside a fraction, is I'm going to have this common denominator of 2 plus h. Alright, now, what's on the top? Let's see here. 3 times 2 is 6. 3 times h is 3h. Plus this 6. Alright, now we have our second part that I'm putting together. Gotta watch the minus sign here. Minus 6 times 2 is a minus 12. And minus 6 times h is a minus 6h. Alright, now, a couple of things. Anytime you can simplify, we're going to make that happen. And so I see here I got a 6, and a minus 12. Well, 6 plus 6 and then minus 12, these numbers are gone. And the other thing I have on the top is I have a 3h minus a 6h. Well, that's going to be a minus 3h. But before I do that, I'm going to write it all out again. So here, whoop, almost all out again. So back up here. I have my limit as h approaches 0. Alright, again I had 3h minus 6h. So that's a minus 3h on the top. Divided by 2 plus h. And then divided by, bigger fraction here, h. Okay. Now, here's another skill to know when you're dealing with math, is if I have fraction divided by a number. And what I can do to solve that when I got a fraction inside of a fraction, is I'm also going to make this h a fraction. And to make anything a fraction, without changing it, you just divide by 1. And so now I have a fraction divided by a fraction. And to get rid of that, or to simplify it, I should say, the way to do that is you take the bottom fraction, you invert and multiply. So instead of dividing by h divided by 1, I'm going to multiply by 1 over h. So that is how we get rid of a fraction inside of a fraction. We invert and multiply. So there's what I have now. Alright, so that instead of dividing by h over 1, multiplied by 1 over h. Multiplied by the reciprocal. Now, what happens in this case, lucky for me, is I have an h in the bottom here and an h on the top. Those divide each other out. And so, we get the limit as h approaches 0. Let's see, on the top here I got negative 3 times 1. Well, that's a negative 3. And then I just have my 2 plus h times 1. Well, that's going to be a 2 plus h. Now, here's the thing. Is again, I want to substitute h is equal to 0 into the equation. But I can only do that if it doesn't give me a denominator that's 0. And in this case, I do have an h in the denominator. But if I substitute in a 0, I don't get 0. So I can substitute it in, which I'm going to do. And so, well, I put a 0 in here. I just have a negative 3 on the top and a 2 on the bottom. And so the slope is negative 3/2. So again, a lot of manipulating our equations there, where I have to get a common denominator, and then I have a fraction inside of a fraction. And to do that, again, I made this h a fraction. And when you have a fraction divided by a fraction, you invert and multiply. So again, a lot of different skills there going on geometric-wise. All right, I'm going to look at our last example now. So example 3. Get rid of this stuff. We'll look at another scenario. All right, so let's see here. Get rid of that. All right, so example 3. It says determine, or no, find the equation of the tangent line. A little bit of extra work here. So determine the, let's get rid of slope and throw in equation. So not only the slope, but the full linear equation of the tangent line. For the curve, let's see here, y is equal to the square root of x at 0.93. All right, so here we go. So again, I'm going to use my definition to find the slope of the tangent line. So again, I'm going to use the limit as h approaches 0. Our x value here is 9, so it's going to be f of 9 plus h minus f of 9 all over h. So try a new black marker here. All right, so let's see here. So that means wherever there's an x, I'm going to put a 9 plus h to start here. So I got the limit as h approaches 0. Let's see here. Y equals the square root of x. So I'm going to have the square root of 9 plus h minus